free valve technology, for example, where supercar technology can also work well in a normal car.
Christian von Koenigsegg, founder and CEO of the high-performance automaker Koenigsegg, revealed a next-generation engine technology that could displace electric vehicles entirely. In a tightly controlled, invite-only event, hidden from the public view and attended by only top automotive elites and industry giants, he introduced the revolutionary engine design.
A monster in itself with power and torque like you can't believe, in a very friendly way.
An innovation that isn't just a step forward, but the start of a whole new automotive era. Inside the camless revolution. Christian von Koenigsegg didn't just stroll onto the event at the old airbase runway in Ängelholm, he owned the moment. Under the soft glare of studio lights, he brought out a short, wide-bodied carbon fiber test mule, tapped a button, and suddenly, silence gave way to something entirely new. Gone was the mechanical chatter of cams and chains. In its place, a clean, sharp hiss. That sound came from dozens of tiny air-driven pistons firing with mind-bending speed and precision. This was Koenigsegg's Lightspeed engine, running on a radical system called free valve. There's no camshaft, no timing belt, just ultra-fast pneumatic actuators, all controlled by artificial intelligence, adjusting every valve hundreds of times per second. That means more power from each drop of fuel and way less waste. This wasn't some wild last-minute invention. Koenigsegg and his engineers have been refining free valve for nearly a decade. Back in 2016, they shocked everyone by fitting it into a little 1.6-liter Koros hatchback. The results were wild: 47% more power, 45% more torque, and 15% less fuel use. All of that, just by ditching the camshaft. That success proved free valve wasn't just a cute gimmick. It could work, even beyond commuter cars. So Koenigsegg's team kept going, upgrading the actuators, improving the AI, and perfecting the oil-air hydraulics until the system was tough enough to survive inside a world-class hypercar. The first real-world result? A beast of a motor nicknamed the Tiny Friendly Giant. It's a 2-liter, 3-cylinder twin-turbo that delivers 600 horsepower. Yes, 600. From an engine that weighs just 154 pounds. Stick it inside the 4-seat Gemera prototype, and this Mega GT goes from 0 to 60 miles per hour in under 2 seconds. Keep your foot down, and it'll hit 248 miles per hour. The trick is constant valve control. At cruising speeds, the engine sips fuel gently. But the second the turbos kick in, the valves snap open fully for maximum power. This lets the engine act calm or crazy, depending on what your right foot is doing. But Koenigsegg didn't stop there. Pair that tiny friendly giant with his new in-house electric motor, the dark matter, and things go nuclear. The motor alone weighs just 86 pounds, but makes 800 horsepower and 922 pound-feet of torque. Put the two systems together, and you get a hybrid pushing out 1,700 horsepower and a jaw-dropping 8,100 pound-feet of torque at the wheels. All of that power gets routed through Koenigsegg's custom 9-speed multi-clutch gearbox, which lets the car instantly jump from one gear to another. It's called Lightspeed for a reason. Still, brute force was never the only goal. Koenigsegg and his team became obsessed with efficiency. Free valve's dyno tests already show it climbing toward the magic number, 50% thermal efficiency. That's nearly double what old-school muscle cars managed. And it's possible because this engine doesn't waste heat. Every cylinder breathes exactly what it needs, no more, no less. When the car's idling, the engine just closes all the valves and waits. It barely uses fuel at all until you press the pedal again. And it's not picky about what you feed it. This engine can run on regular gas, pure methanol, Brazilian ethanol, even synthetic e-fuels made from captured carbon and clean electricity. Fill it up with Sweden's E95 biodiesel or straight-up e-methanol, and you get almost net zero carbon emissions, without needing to dig more lithium or strain the power grid. But talk is cheap in the world of supercars. So in early June 2025, Koenigsegg opened up the old Air Force hangar at their headquarters in Ängelholm and invited a few test drivers and journalists to see the thing run. They watched a stripped-down Gemera prototype, still wearing sensors but no camouflage, rocket down the runway on a tank filled with 95% ethanol. It hit 60 miles per hour in just 1.9 seconds, again and again, and braked well before the markers at the end. The test logs showed every detail: exact valve events, fuel trim adjustments, exhaust temps. The onboard AI was making real-time tweaks, shaving off drops of fuel while keeping the engine cool enough to protect the turbos. Those who were there described something surreal. It sounded like a normal engine, but not quite. The classic cam lobe rhythm was gone. Instead, it hummed smoothly, while the turbos screamed like jet engines. Drivers said the throttle response felt instant. No delay, no turbo lag, no sluggish valves. Just pure, unfiltered boost the moment their foot moved. One old-school engineer even joked that it felt like a volume knob for torque, because that's what it is. The magic isn't just in the engine's lungs, but in its brain. Every actuator is wired to high-speed sensors inside each cylinder, and the main computer is trained on millions of combustion cycles. The engine changes strategy on the fly. It can act like an Atkinson cycle, a Miller cycle, or even pull off quick two-stroke moves, depending on load, RPM, and how aggressive the driver is being. Cruising on the highway, it'll shut down 2 of the 3 cylinders to save fuel, but switch to track mode, and it loads up full lift profiles, pulling in as much air as possible and firing every 90 degrees of crank rotation. That means non-stop power with no wasted strokes. And it's tiny. By removing the cams, gears, belts, and bulky timing covers, Koenigsegg chopped about 8 inches off the engine's length and trimmed more than 70 pounds compared to a regular twin-turbo V6, making similar power. That smaller size lets designers do more, like move the passenger cabin forward, boost crash protection, or even make space for luggage in a 4-seater that can outrun most motorcycles. So what does this mean for the future? Everyone keeps saying electric is inevitable, but Koenigsegg just smiles and shrugs. Standing next to a humming prototype, he says, "Why not have both?" With the Lightspeed engine, he's proving that combustion can change. It can get cleaner, it can be smarter, and it can still deliver that raw, emotional thrill drivers crave, without asking the planet to pay the price. It might not be the perfect solution, but it flips the argument. And how does this camless machine compare to the tough realities that battery cars still face? EV reality check. Koenigsegg's wild new Lightspeed engine already turned heads with its insane performance and that eerie camless hiss. But Christian von Koenigsegg knows none of that matters unless it stacks up against the one thing everyone's talking about: electric vehicles. For the past 10 years, EVs have been sold as the clean future, the gold standard. So before we dive into how Koenigsegg might scale his invention, we have to be real about where the EV world actually stands in 2025, and what problems it's still dragging along. There's no denying the momentum. In just the first 3 months of this year, drivers around the world bought a little over 4 million all-electric cars. That's about 35% more than the same period last year. If that pace keeps up, the world will cross 20 million EV sales by year's end. That's roughly 1 out of every 4 new cars sold globally. Most of that is coming from China, which is miles ahead of everyone else. The United States grew by about 10%, while Europe stayed flat at around a 20% share of total sales. But when you zoom in, the picture gets messier. Europe's car sales actually dipped in June, down about 4.4%. And even though EVs passed the 1 million mark for the first half of the year, most of the new sales came from cheaper Chinese brands like BYD. That growth chipped away at the market shares of Tesla and Stellantis. Over in the US, battery cars still make up only about 10% of new vehicle sales. High interest rates and a shift toward cheaper gas-electric hybrids are slowing things down. Behind the scenes, EVs rely on a tangled global supply chain that would make any Koenigsegg engineer flinch. The raw materials that go into a typical lithium-ion battery travel more than 50,000 miles before that battery is even built. That's enough to circle the planet nearly twice. And every ship, truck, and train along the way burns fuel, which adds a layer of hidden carbon emissions to a product that's supposed to be green. Take cobalt, for example. About 70% of all cobalt used in the world is mined in the Democratic Republic of Congo. Then, roughly 70% of that gets refined in China. That's a lot of reliance on just 2 places. And it's not just a logistics issue, it's a moral one too. According to a recent audit, there were 270 reported cases of labor or environmental abuse at mining sites in Eastern Europe and Central Asia during 2024. That's nearly 3 times the yearly average from the past 5 years. Many of those cases involved copper and nickel mines, both critical for EV batteries. Unless the entire mineral map shifts overnight, every added gigawatt-hour of battery production only deepens the industry's dependence on a few high-risk areas. Now, recycling is supposed to help fix that, and the science is starting to catch up. A study led by Stanford earlier this year showed that modern hydrometallurgical recycling methods can cut greenhouse gas emissions by 58 to 81% and use up to 89% less energy compared to digging up fresh ore. The problem isn't the tech, it's the collection. Less than half of dead EV batteries ever make it back to a proper recycling facility. Most just sit around collecting dust in garages or end up in landfills, taking all that valuable nickel, manganese, and cobalt with them. And then there's charging. Right now, the US has about 219,000 public charging ports. Sounds like a lot, until you realize only 1 in 5 of those is a fast charger. Compare that to the 160,000 gas stations in the country, most with 10 or more fuel pumps that can refill your tank in 5 minutes flat. Setting up fast chargers isn't cheap either. According to the National Renewable Energy Laboratory, upgrading one rural location to have just 4 fast charging plugs at 150 kilowatts each could cost up to $4 million. If you use battery buffering tech, that drops the price by about 2/3, but it still costs someone millions. Now multiply that across the tens of thousands of charging sites needed to make road trips convenient, and the price tag starts looking like another interstate highway system. So eventually, every EV buyer has to ask the same thing. How much carbon does my car really produce once I hit the road? Let's say you own a mid-size battery-powered SUV that uses 28 kilowatt-hours to go 100 miles. On today's US power grid, that means your car is responsible for about 0.81 pounds of carbon dioxide per kilowatt-hour. Multiply that out, and it adds up to roughly 0.23 pounds of carbon dioxide for every mile you drive. Now let's put that next to Koenigsegg's Lightspeed engine, running on synthetic e-methanol made from captured carbon and wind energy. There's already a methanol-powered sedan from Geely on the market that emits about 0.016 pounds of CO2 per mile. Koenigsegg wants to push that even lower by boosting engine efficiency to 50%. If he pulls it off, emissions could drop closer to 0.011 pounds per mile. That means his 3-cylinder, running on recycled carbon fuel, could emit around half the carbon of an average electric SUV on today's grid, and it won't make you wait in line for a charger. This isn't about saying combustion is better or electric is worse. Every powertrain comes with its own trade-offs. EVs shift the carbon problem from the tailpipe to the power plant and the mine. Combustion engines move it from the mine to the refinery and back out the tailpipe. The real question is which trade-offs are easier to fix, and how quickly each side can clean up its weakest links. Koenigsegg is betting that a superlight engine that runs on whatever carbon-neutral fuel the future throws at it might avoid the worst parts of the battery problem while still using the thing drivers already know how to find: a gas pump. So here's where things stand today. Electric vehicles are growing fast, but that growth is uneven. Their supply chains still depend heavily on a few politically shaky countries. Battery recycling is improving, but not nearly enough batteries get collected. Charging networks are expensive and still nowhere near as convenient as gas stations. And the actual carbon footprint depends on how green your local power grid is. If Koenigsegg can take everything that makes his Lightspeed engine special and bring it to the mainstream, those numbers could start to change. But that brings us to the big question. How in the world do you scale something like this? Scaling the disruption. Christian von Koenigsegg's camless prototype already proved it can blow past some of the fastest electric vehicles out there, but raw speed is just the side story. The real challenge is figuring out how this high-tech, AI-controlled engine setup could ever show up under the hood of everyday cars, the ones that carry families, haul cargo, or race to emergencies. Koenigsegg's answer? Don't go it alone. Instead, take a page from Toyota's playbook. Open up the patents, license the technology, and let the big automakers with massive factories handle the scaling. FreeValve's own website now confirms that they're already working directly with several original equipment manufacturers and top-level suppliers. In other words, this isn't just an idea anymore. It's happening behind closed doors. Inside the auto industry, people are comparing this to what Toyota did back in 2019 when it unlocked 24,000 hybrid patents. That one move helped spread hybrid tech across the world and turned the Prius system into a global standard almost overnight. Of course, moving from a hand-built prototype to mass production is no small task. Each valve in Koenigsegg's system has its own fast pneumatic actuator and a precision sensor that knows its position, down to a tiny fraction of an inch. Machining all of that to tight tolerances is expensive, unless a major supplier steps in. Koenigsegg's team has proposed what they call a modular head kit. It's designed to fit right onto the kind of engine blocks automakers are already making by the millions, iron or aluminum castings, while the complicated, delicate parts are handled by a specialized outside vendor. This setup could cut costs dramatically. Internal estimates shared with potential partners suggest that once production hits 500,000 units per year, each actuator could cost around $900. That's less than the cost of the 8 kilowatt-hour battery pack many budget electric vehicles still need just to support stop-start features. So for traditional automakers looking to reduce emissions without scrapping their current engine designs, this becomes a very appealing upgrade. It gets even more compelling for commercial vehicles. A battery-powered delivery truck can weigh up to 11,000 pounds more than its diesel version. Even with a 2,000-pound weight allowance from federal rules, that still leaves 9,000 pounds of lost payload. For a big rig carrying 40 tons, that means losing about 9% of what it can haul, and that's money lost on every trip. Swap in a 6-cylinder running Koenigsegg's light speedhead on e-methanol, and the truck gets its full cargo capacity back, refuels in minutes, and uses components mechanics already know how to fix. Emergency vehicles like fire trucks and relief tankers need that same kind of reliability and fast turnaround. Free valve tech offers that, along with long idle times without sucking fuel or overheating. The timing couldn't be better. Europe's plan to ban combustion engines by 2035 now makes room for synthetic fuels, after Germany pushed for an exception. That new loophole gives breathing room to engine makers who are investing in clean-burning fuels instead of switching entirely to electric. Koenigsegg's engine maps already support gas, ethanol, methanol, and even blends like e-diesel. That flexibility fits perfectly into the new rules, and there's more going on outside the usual markets. In sub-Saharan Africa, nearly 600 million people still don't have access to electricity. On average, each person uses less than 200 kilowatt-hours of power a year, about the same as an American dishwasher. Fast-charging networks aren't arriving there anytime soon, but many of these regions already distribute sugarcane ethanol or can make methanol locally. Koenigsegg's flex-fuel camless engine could let these areas jump straight to cleaner transportation without needing huge electric infrastructure or rare earth materials. That practicality is why the big engine makers are starting to take notice. Cummins recently showed off a 15-liter hydrogen diesel hybrid and called hydrogen combustion engines a bridge technology. Two executives who were at that event in Hanover confirmed that Cummins has tested FreeValve's actuator system on a hydrogen-burning 6-cylinder. They were looking for better startup performance and cleaner emissions than traditional camshafts could offer. Nobody's saying much publicly, but insiders revealed that Cummins engineers visited Koenigsegg's facility in Ängelholm twice this past spring. That alone says plenty. At the same time, reports in China suggest that BYD, the giant behind many plug-in hybrids, has explored using a small free-valve-powered engine as a generator in a range extender setup. Neither company is talking publicly. Koenigsegg won't comment, and BYD keeps highlighting its own in-house hybrids. Still, the rumor alone shows how valuable a tiny 50% efficient engine could be, especially if it helps EVs go farther without ballooning their battery packs. But none of this matters unless the supply chain catches up. Koenigsegg's internal forecasts show that if just 2 major automakers each install this head on 250,000 vehicles per year, actuator costs drop below $600 each. At that point, the entire valve system becomes competitive with modern variable cam setups. FreeValve's own milestone chart quietly mentions a deal with a heavy-duty diesel customer all the way back in 2018. That's not just a lab experiment. Real purchasing departments are signing real contracts. Another milestone from 2020 tied the system to the Gemera, but insiders say the 3-cylinder engine was always a test bed. The real goal is light trucks and work vans, where updating the engine block is a lot cheaper than switching to batteries. Suppliers are already laying the groundwork. Bosch has built prototype actuators made from lightweight composite materials that cut moving mass by 30%. Mali, another major parts maker, has tested a 6-channel valve controller that works with the same computer systems they already supply to automakers. Both companies are keeping quiet officially, but if you walked through their booths at CES 2025, you'd see demo hardware labeled independent valve actuation modules that just happen to match FreeValve specs. Regulators are watching all of this closely. If a 4-cylinder running e-methanol can match the full carbon footprint of a mid-size electric vehicle, start to finish, lawmakers suddenly have a much easier path. They get to protect jobs at engine factories while still hitting environmental goals. That's why several European countries insisted on the synthetic fuel exception last July. It's also why California's Air Resources Board quietly funded a study comparing FreeValve's setup with a 300-mile EV using today's grid. Early results show the emissions are basically equal, but Koenigsegg's engine avoids the massive mineral demands of a 70 kilowatt-hour battery. When you put it all together, the tech, the cost, and the politics are finally lining up. If Koenigsegg can get his modular heads out of low-volume workshops and into full-scale production, this won't just be about hypercars anymore. Pickup trucks, school buses, tractors, anything that runs on liquid fuel today could cut both its emissions and operating costs without ever needing a charger. The partnerships are forming, the policies are shifting, and the pieces are falling into place. But what will this mean for drivers, regulators, and the car culture itself? The new automotive truce. Lawmakers, auto companies, and drivers are all changing course at the same time. In July, the European Parliament quietly rewrote part of its zero-emissions policy to allow cars that run on certified synthetic fuels to count alongside electric ones. That shift came after Germany, and Italy pushed back, arguing that advanced engines like Koenigsegg's Lightspeed deserve a shot, especially if they run on carbon-neutral fuels. Meanwhile, in the United States, regulators are moving in a slightly different direction, but one that could shake things up just as much. The Environmental Protection Agency opened a new rulemaking process that would score cars based on total carbon emissions from start to finish, not just what comes out of the tailpipe. That change could allow high-efficiency engines like Koenigsegg's to earn the same green credits that are currently reserved for zero-emission electric vehicles. The auto industry's response has been anything but quiet. What looked like a solid bet on battery-only vehicles now feels riskier. Toyota, often mocked for trying everything, hybrids, plug-ins, hydrogen, and e-fuels, now looks like the smart one. Back in May, company leaders told investors that this spread-out strategy protected profits while other brands were burning cash on massive battery plants. Porsche has already put real money into its Haru Oni project in Chile, which is on track to produce 130,000 gallons of e-fuel this year. They're also building much larger plants in Texas and Tasmania before the decade ends. BMW joined the push in October, teaming up with HIF Global to co-finance their next synthetic fuel refinery. Even Tesla, the face of battery-powered cars, is shifting focus. The company's energy division doubled its revenue last year to $10 billion, proving Tesla now sees big profits in storing power, not just in selling cars. But there's more to this shift than numbers. Not everyone drives just to get from point A to point B. Many still crave the feeling of a real engine. SlashGear's year-long series on drivers who refused to give up manual gearboxes broke traffic records. People kept coming back to the same reasons: sound, vibration, and a sense of control. They said that's what's missing from most electric cars. Koenigsegg's Lightspeed engine speaks to that crowd. It delivers the sound and feel of combustion without the climate guilt, cutting carbon emissions close to zero when it runs on renewable methanol. So drivers still get the thrill, while regulators still get to sign off. The economics are catching up too. Bloomberg NEF's most cautious projections still show that entry-level battery SUVs could cost the same as gas-powered ones by 2028. But Koenigsegg's internal supplier estimates put a Lightspeed hybrid powertrain within $2,000 of that price point, as long as synthetic fuel is taxed at the same rate as regular gasoline. And in places where ethanol is already blended into the fuel supply, that price match could happen even sooner because the infrastructure is already there. Jobs are just as important in this equation. A recent study by the International Council on Clean Transportation found that battery cell factories need about 144 workers per gigawatt hour, but most of those jobs are concentrated in just a few big facilities. On the other hand, a camless retrofit strategy like Koenigsegg's spreads the work across existing engine plants, assembly lines, and dealerships. That keeps more people employed in more places. It's a model that unions in the US Midwest and lawmakers in Germany are now paying close attention to. They worry that if battery megafactories become the only game in town, jobs and value could drain out of their home regions. Looking ahead, the data points toward a future of coexistence rather than one technology beating all the others. Bloomberg NEF now expects global sales of electric passenger cars to pass 39 million per year by 2030, with battery vehicles eventually dominating the market. But the International Energy Agency's net zero roadmap shows the fastest emissions cuts come when small, high-use city cars go electric, while heavier-duty vehicles in rural areas rely on ultra-efficient engines burning low-carbon fuels. That kind of mixed system lets each technology do what it does best, instead of trying to force one solution on everything. Right now, the pieces are coming together. Governments are writing rules that allow any clean technology to compete. Automakers are investing in synthetic fuel plants just in case batteries don't go the distance. Drivers are still drawn to the emotional power of real engines, and the price gap between options is closing fast. Christian von Koenigsegg has said it before, there's no need to pick just one path. Innovation isn't a zero-sum game. Whether you end up with a whisper-quiet motor or a fierce, camless growl, the real win is having choices. Because the best drivetrain for you might not be the best for someone else. And for the first time in a long while, that choice is finally back in your hands. Thanks for watching. See you in our next video.